now I am going to discuss about the design of splice plate due to shear. Today's lecture will be the continuation of the previous lecture. In previous lecture, we have discussed about the design methodology or design steps for splice plate, and a splice plate may undergoes due to axial compression, then moment, and because of moment tension may come, and also shear may come into picture. So, we have gone through one example and we have shown that how to design the splice plate due to axial compression and moment. And we have seen that due to axial compression, certain compressive force will come into splice plate, and due to bending moment also certain amount of force will come onto the flange, and because of that we need to design the splice plate because of combined action, and the splice plates are designed through the connection through its flange, because the bending and compressions are designed in the flange, and shear will be taken care by the wave. Therefore, we will be design a wave splice for shear. And so, if we recall the earlier diagram, wave splice for shear, we can see that it is something like this. Say columns are spliced by bolt connection. So, this is the column flanges which are spliced due to complete bearing. So, here we have provided certain number of bolts to splice them, right. So, and this splice plates can take care the axial load as well as the moment, but the shear force will be taken by the wave, because we know the shear force is generally taken by the wave of the plate. So, in case of wave splice for shear, we need to provide some plate here, right. So, now I need to know what will be the dimension of the plate, what will be the number of bolt required to join to withstand certain shear force. So, this is basically wave splice for shear. So, I will go through one example, and that example is nothing but the previous example which we have discussed in earlier lecture. So, first part I will just give a brief summary of that, means whatever we have done in earlier class, we will just go through that very quickly, and then to just remind this dimensions and other things, right, and then I will design the splice plate on the wave. So, this is the example we can consider which was worked out in last lecture, that is the column of ISHB 300 and carrying a load of 500 kilonewton and shear force of 120 kilonewton and bending moment of 40 kilonewton, and we need to design the splice plate connection using 4.6 grade of bolt, right. So, for this we have designed the splice plate due to bending moment and axial force, and for designing that, first what we did, we found the cross sectional area of the column section from table 1 of SP 6, thickness of the flange, width of the flange and width of the wave plate which will be required, and also some material properties like FUB, FU, FY and their partial safety factors has been noted. So, after that what we did is that we have assumed it as a complete bearing, and from that we found the direct force as 125 kilonewton, that is P by 4 basically, and the moment mu by force due to moment as mu by lever arm, and that we found as 130.72 kilonewton. And whereas we have assumed splice plate thickness as 6 mm. So, the design load for splice we could calculate, that is Pu 1 plus Pu 2, which is coming 255.72 kilonewton, and from that we can find out the sectional area required, which is Ps by Fy, which is coming 1022.9 millimeter square. So, once we find the sectional area, we can find the thickness of the splice plate, because the width can be considered as 250 millimeter, which is the width of flange. So, flange width of the member is 250. So, that we can consider as the width of splice plate, keeping same. And so, the thickness of the splice plate we can find out simply by cross section by width, which is coming 4.09 millimeter, and it should not be less than 6 mm. So, we can provide at least 6 mm splice plate. And also for finding out the number of bolts, we have to assume certain diameter of bolts. So, in this case we have assumed 20 millimeter diameter of bolts, and for that we can find out the strength of the bolt due to single shear, which is coming 45.26 kilonewton, where A and B is a 244, which is 0.78 pi by 4 d square, and FUB is 400. So, from this we can find out. So, again we need to find out the strength due to bearing. So, that also we can find out from this formula 2.5 kb dt Fu by gamma mb. So, for that first we have to find out the value of kb, and to find out the value of kb we need to know what is the edge distance and what is the pitch distance. So, as per the codal provision, at least the edge distance has to be 33 and pitch distance has to be 50, and we have provided as 35 mm edge distance and 60 mm pitch distance. So, then we can find out the value of kb, which should be smaller of E by 3 d 0 and P by 3 d 0 minus 0.25, FUB by FU and 1. So, from this calculation we could see that the value of kb is becoming 0.53, which is the smallest one. So, once we find out the value of kb, we can find out the strength of bolt in bearing. So, strength of bolt in bearing I can find out by providing the necessary values of the parameters like 2.5 kb dt into Fu by gamma mb. Okay. So, from this we can find out the value of strength in bearing as 52.15 kilonewton. So, so strength of the bolt will become the smaller of these two, one is strength in shearing and strength in bearing, and smaller of these two we could find as 45.26 kilonewton. So, if the strength of bolt is 45.26 kilonewton, then the number of bolts required can be found. So, that can be found from this formula, that is the total load in the splice divided by bolt value. Total load in splice means total compressive load or axial load I should say. So, from this we can find out the value as 5.65, that means 6. So, we need to provide 6 number of bolts for each splice. So, for each splice if we provide 6 number of bolts, that means if we see that 6 number of bolts means 3 number of bolts in this position and 3 number of bolts in this position. So, we can provide 3 number of bolts. So, according to that we can find out the length of the splice plate. So, length of the splice plate to accommodate 3 number of bolts this and then into 2, so 380 millimeter. So, finally, we can provide a splice plate of 380 by 250 by 6 mm on column flange as shown in the figure. Figure I will show at the end of this lecture. Now, splice plate for shear. We will see how to find out the splice plate dimension due to shear. So, let us calculate step by step for splice plate due to shear. So, if we use 20 mm diameter of bolt, then the strength of bolt in double shear it will be, that means VDSB double shear will be 2 into 45.26 kilonewton. This 45.26 kilonewton we have calculated earlier due to strength of bolt due to shear, single shear, right. And here as bolt means plate should be provided in two sides of the wave, right. So, if we provide like this, so plate will be provided in two sides, so it will be in double shear. Therefore, the strength of bolt will be calculated due to double shear and which will be coming 90.52 kilonewton. And similarly, strength of bolt due to bearing, that we can find out VDPB. So, that also can be found out as 2.5 kb dTFU by gamma mb, right. So, now kb we have calculated earlier, because we are providing same pitch and edge distance. If we consider same pitch and edge distance, then we can provide kb as 0.53 as we calculated earlier. D is 20 mm diameter bolt and T is the thickness of the plate. Here thickness of the plate will be the thickness of the smaller plate. That means, here wave thickness is 7.6, right. So, the smaller one is 7.6. So, 7.6 into 410 by 1.25, right. So, that will become 66.06. Smaller means here actually if we provide two splice, then its thickness will be total 12 mm and thickness of the wave will be 7.6. Therefore, we can consider the smaller one, right, considering 6 mm thickness of splice plate. So, we are getting 66.06 kilonewton as strength in bearing. So, we can find out the strength of 20 mm bolt is becoming lesser of these two, strength due to shear, double shear and strength due to bearing. So, we can find out as 66.06 kilonewton. So, the strength of bolt finally we found as 66.06 kilonewton. Now, the shear force was given as 120 kilonewton. So, if the shear force is this, then I can find out number of bolts required will be 120 by 66.06. So, 1.8, that means 2 number of bolts. So, 2 number of bolts if we provide on each side of the splice, then we can find out length of the splice plate. So, if we draw 2 number of bolts. So, if this is a splice plate and this is the column, this is the wave of the column, and then if we provide 2 number of bolts in each side, then the we can find out length. Length will be this will be 35, because the edge distance is 35. So, this is 35 and this is 35. So, total will be 35 into 2 70 and again 70, right. So, finally, length will become 4 into 35. So, 140 mm. So, length of the splice plate will become 140 mm. Similarly, width I can find out. Width will become this will be 60 and this is 35 and this is 35. So, finally, width will become say W as 60 plus 2 into 35. So, that is 130 mm, right. So, length and width of splice plate can be found as 140 by 130. Now, I have to find out the design shear strength of the splice plate, because I have to see whether the design shear strength of the splice plate can be, the splice plates can take that much shear which are applied externally, and by equating that from with design shear strength with the external shear, we can find out the thickness of the splice plate. So, first we can find out the design shear strength. If that is V d, we can write F y by root 3 gamma m 0 into h into t, where h into t is the area, cross sectional area. So, here if we put the value 250 by root 3 into gamma m 0 is 1.1 into h is 130. So, this W we could find out here, it is 130, and T is the thickness of the splice plate. So, here two splice plates are provided in two sides. So, I can provide 2 into T s. T s is the thickness of the splice plate, right. So, if we make, we can find out 34.12 into T s kilonewton. If we make kilonewton, I have to multiply it 10 to the minus 3. So, V d, the design shear strength, can be found as 34.12 into T s, where T s is the thickness of the splice plate. So, with respect to thickness of the splice plate, the design shear strength of the same has been calculated. Now, we can make equal V d equal to V, so that I can find out the value of T s. So, V d is 34.12 into T s, and V was 120 kilonewton. So, from this I can find out the value of T s, which is the thickness of splice plate, that will be 120 kilonewton by 34.12. So, that is becoming 3.52 millimeter. So, it should not be less than 6 mm, right. So, at least we have to provide 6 mm splice plate. So, the we can provide a pair of 140 by 130 by 6 mm shear splice plate at each side of the web. Okay. So, now if we draw the total diagram to see the splice plate and its weld distribution, then we can see that in front view it will be like this. Say this is the column, here two columns are spliced, and okay. So, front view of the column will be like this, and these are spliced at their flange, like this. So, we have provided 2 number each. So, this is one bolt, this is another bolt, similarly this is one bolt, this is another bolt. So, total 4 bolt at each side, right, at the flange. This we have done, and this is ISHB 300, and the dimensions will be like this. If we see, it will be 35, then 60, then 35, 35, 60, 35, right. and also it is spliced in its wave. So, in the wave we can see the splice plate is provided here, whereas total number of 4 bolts are made and pitch distance was considered as 60 and this is 35, this is 35, and here it will be 35, 35, 35, 35. So, that means this will be 140 and this will be 130, right. So, size of the splice plate is 130, in two sides it has been done. This is front view, we can see this, and in side view we can see, say you can see like this. So, this is the place where the columns are spliced. So, the column and the splice plates are this, and we are providing total 6 number of bolt in each splice. Okay. So, this is 20 mm diameter of bolt, right. This is side view, and the column size is this ISHB 300. So, this is how we can find out the details of the splice plate this way, right. So, to go through once again quickly, or just to give an overview of the discussions what we did, we can see that first what we did, we have found the dimension of the splice plate. So, for that first we assume certain diameter of bolt, which we in this case we have considered 20 mm diameter of bolt, and therefore, the strength of bolt in double shear we could find out as 90.52 kilonewton, and similarly as Kb is found already 0.53 for edge as 35 mm and pitch as 60 mm. So, we can find out strength in bearing. So, 2.5 Kb d T, remember here T is 7.6 mm, which is the wave thickness. Now, in the splice, if we consider the splice plate thickness is 6 mm. So, in two sides we have provided splice plate in the wave. So, the total thickness will be 12 mm. So, we have to consider either 7.6 mm or 12 mm, whichever is less. So, for this we have considered 7.6, and considering that we found the strength in bearing as 66.06 kilonewton. So, the strength of 20 mm bolt is 66.06 kilonewton. So, this is what we found. Then we can find the number of bolts, because the shear force in the wave was given as 120 kilonewton. So, number of bolts required will be 120 divided by 66. So, that is coming 2 number of bolts. So, in each side of the splice we can provide 2 number of 20 mm diameter bolts, right. So, the length of the splice plate will become 4 into 35, and the width of the splice plate will become 60 plus 2 into 35. That how it has been calculated, I have shown in earlier by through the diagram. So, I am not going into details. So, the splice plate dimensions can be fixed as 140 by 130. Now, we have to find out the thickness of the splice plate. To find the thickness of the splice plate, we have to find out the design shear strength. Now, design shear strength we can calculate the allowable shear stress of the plate into cross sectional area. Now, cross sectional area will be H into T. T is the thickness. So, here two plates are provided in opposite side in the both side. So, it will be 2 into T s. So, if we provide this value, whereas H is equal to 130, then we can find out the design shear strength will be 34.12 kilonewton. So, this has to be equate with the external shear force acting on the column, that is 120 kilonewton. So, if we make equate with this condition, then I can find out the thickness of the splice plate should be more than 3.52 millimeter, and in any case it should not be less than 6 mm as per the codal provision. Therefore, we can provide 6 mm thickness of the splice plate. So, let us provide 140 by 130 by 6 mm shear splice plates on each side of the wave, and the details have already been shown, which again I am showing here. So, here we can see that according to the age and pitch, we have found the total length of the splice plates in the flange, and number of bolts also total 6 in each direction, in each side. So, this we have distributed, and in the wave the total number of bolts will be 4, means 2 in each case, and the dimension will be 140 by 130, thickness will be 6 mm. So, this is how the detailing has been made. So, in this lecture what we can see, this is basically a continuation of the previous lecture, in which we have shown how to design the column splice when the column is subjected to not only the axial force, but also bending and shear. Now, if only axial forces are considered, then we do not need to provide wave splice, only flange splice will be sufficient for axial and bending, and for shear we have to provide wave splice, right. So, this through this typical example means when 3 type of forces are acting, whereas that means the axial force, bending moment and shear force. Then how to design the splice plate considering its connection. Connection means if we consider the bolt connection, how to find out the number of bolts and how the arrangements will be done, what should be the plate thickness of the splice, those has been demonstrated through that example. So, I hope this will be made clear on the design of splice plates. Thank you.